You'll have to work this one out. Alright, this video today is going to focus just on that top box there. Quite a nice short video, but we'll go over the specifics that you need to know for your exam. So the starting point of the geology video is just to go over these two very important words: a concordant coastline and a discordant coastline. A concordant coastline means that only one rock type faces the sea. And generally speaking, when you look at those down a map, they'll be hard rocks, because if they were soft rocks, they would have been eroded away by this point. The opposite to that is a discordant rock, which has different rock types that face the sea. So for example, you might have a couple of hard rocks, you might have a couple of soft rocks, or you could simply have one hard rock, one soft rock. That would still count as discordant because you've got many types of rock facing the sea. Now in your study of GCSE, you have examples of both of these. You have a concordant coastline, which, just to remind you, is only one rock type facing the sea, and that would be sandstone, and this occurs at Dawlish Warren on the South Devon coastline. The South Devon coastline to the west of Dawlish Warren or Langston Rock is all just sandstone, so it's only one type of rock facing the sea. Relatively uniform in erosion. What I mean by that is, generally speaking, the sandstone erodes at a relatively similar rate. Hopefully you can see that in the image there, that the cliffs are almost in a straight line. They're generally the same height, and obviously human beings have got involved and built walls in front of them, but as a general rule, that sandstone would erode at a relatively even rate. Likewise, weathering, your subaerial processes would also happen at a relatively even rate. Obviously there'll be some natural variation, as there is with any rock, but generally speaking, on a concordant coastline you get a relatively stable rate of erosion. And just to repeat there, the coastline generally straight. So that image is from Langston Rock, which is your headland, looking towards the west hand side. You also have a discordant coastline, which is the St Austell Bay case study example, and that's, remember, where two different rock types face the sea. Because you have two different rock types facing the sea, you end up with differential erosion, and in this lovely example, if you come across to the map here, hopefully you can see that orange dashed line running across that. At one point in history, it would have been tens if not hundreds of thousands of years ago, you would have actually had sandstone and slate marking the gap between Blackhead and Gribbenhead. So at one point, sandstone and slate would have filled that entire area. However, because sandstone and slate erodes faster than pure slate that you find at Gribbenhead and Blackhead, that area has eroded far faster. In addition, weathering happens at a different rate. Sandstone is more susceptible to weathering on the basis that it's permeable, so water can get trapped within the pores of the rock and therefore lead to freeze-thaw weathering. As a result of this, you end up with an uneven coastline, where the sandstone and slate has eroded far faster, leaving your headlands of Blackhead and Gribbenhead sticking out into the sea, while the bay has been eroded far back into its modern day position. So a discordant coastline, you're likely to see more coastal features, or certainly larger scale coastal features like headlands and bays. Last little bit of this video is just to remind you of your rock types. We have granite and slate are two examples I would like you to know of impermeable, resistant rock that can support its own weight. You'll see how vital can support its own weight is going to be as we go through this series of videos. Second rock to be aware of is sandstone. That one erodes at around about 1 metre a year, as opposed to slate and granite you can see above. Sandstone's a permeable rock. It will allow water through it, and it is a less resistant rock than granite and slate. However, the complicated bit here is that it can actually support its own weight. So if you took the bottom out of sandstone like a wave-cut notch, it actually can support its own weight. One other difference to be aware of here is that sandstone has clear layers in the rock, and the reason for that is it's sedimentary rock, which are layers upon layers of built-up material being compressed down to form rocks that we would see today. As opposed to granite and slate, well, slate slightly does, but granite certainly, you can't see the layers within that rock. You'll see how important those layers are going to be in a moment when we talk about the formation of erosion landforms, as those layers will provide a weakness for the sea to exploit. Your third and probably most complicated rock type to be aware of is your Breccia Sandstone, which is a composite of sandstone, boulders and mudstone. It's slightly more resistant than sandstone, and that's why you find that at Langston Rock, the headland that sticks out just ever so slightly further than the rest of the South Devon coastline. It's a very jagged rock. There is an example actually in H1 if you wanted to go and see it. Very, very, very jagged rock, and we'll come back to why that's so important in the future as well. I should also add here that breccia also has clear layers within the rock. Now the last one isn't actually a geology, but you're going to need something that can't support its own weight, and sand dunes is a great example of that. If you take out the bottom layer of a sand dune, the layer on top will slump down because the sand cannot support its own weight. Another example would be Boulder Clay, but we don't use that case study anymore. If you imagine individual particles of clay, if you took the bottom out of anything supporting those clay particles would fall down to earth under the force of gravity. So there's your starting point for your coast videos. Come and see us down in H8 if you are not so sure about anything here.